Hello, it's Rajesh Kumar from AIC. Today we will discuss about the quantitative analysis of the organic compound. The quantitative analysis means the estimation of the amount of an element in a given sample in terms of its mass percentage, mole percentage or volume percentage is called quantitative analysis. Most of the constituent elements can be determined by different methods. As for example, we are going to estimate the amount of carbon and hydrogen in a given organic sample. So, this is also called Liebig's combustion method. So, determination of or estimation of carbon and hydrogen, or it is called Liebig's combustion method. In this method, in the estimation of carbon and hydrogen, a specific device is applied that is called Liebig's tube. In this tube, the sample is placed in a boat and kept inside the Liebig's tube. In this tube, some cupric oxide is also present there. And in this tube, some hot air, heated dry O2, means the oxygen free of carbon dioxide, is passed through this one. In this sample, the carbon compound is oxidized. The carbon of the compound is oxidized into CO2 and hydrogen is oxidized into H2O. This CO2 and H2O is collected by the water absorber and CO2 absorber, that is anhydrous calcium chloride and KOH solution. In this tube, pre-weighted some amount of calcium chloride is being kept. Also, pre-measured or weighted potassium hydroxide is present there. When H2O is passed through this very tube, this calcium chloride get hydrated and its mass will increase. And also the mass of KOH will also increase by absorbing CO2 gas. Rest other excess of oxygen pass through this one, through the guard tubes and so on. Okay. Afterwards, we made the calculation here. So calculation for the determination of the carbon and hydrogen. Mass of CaCl2, that is suppose equal to W1. Sorry, for carbon, mass of CO2 is equal to increasing mass of KOH, that is equal to W2 gram. Got it? No. So W1 could be the mass of water liberated there, and W2 could be the mass of carbon dioxide liberated there. From this water molecule and carbon dioxide molecule, what has been liberated, that increase the mass of KOH as well as CaCl2 anhydrous CaCl2 will give information about the and will help us to determine the amount of hydrogen percentage. How? Now come on. The molar mass of H2O is equal to 1 into 2 plus 16 is equal to 18 gram. So 18 gram of H2O, as per stoichiometry, 18 gram of H2O contains 2 gram of hydrogen. Therefore, W1 gram of H2O will contain 2 upon 18 into W1 gram hydrogen. Similarly, 44 gram of CO2 contains 12 gram of carbon. Therefore, W2 gram of CO2 will contain 12 upon 44 into W2 gram of this one. Okay, of carbon. So, the mass of hydrogen in the H2 liberated is 2 by 18 into W1, and mass of carbon in CO2 liberated is here 12 upon 44 into W2 gram. Now we have to determine in a given sample what percentage of carbon and hydrogen would be for this. Therefore, we can say in given sample amount of hydrogen is 2 by 18 into W 1 gram, and amount of carbon is in given sample is here 12 by 44 into W2 gram of this one. So we can write W gram. Here we will discuss, let the mass of sample is equal to W gram. Therefore, W gram of sample contains 2 by 18 into W1 gram of hydrogen. Therefore, 100 gram of this sample will contain 2 upon 18 into W1 by W into 100. So this is the total percentage of this one. Similarly, W gram of sample contains 12 by 44 into W2 gram of carbon. Therefore, 100 gram of this one sample will contain 12 upon 44 into W2 upon W into 100 gram of this one. So total percentage is this here. That is, overall we get a formula for this one is here. Mass percentage is equal to of hydrogen is equal to 2 by 18 into weight of H2O upon weight of sample into 100, and similarly mass percentage of carbon is equal to 12 by 44 into weight of CO2 upon weight of sample into 100. In this way, we can determine the weight percentage of carbon and hydrogen in a given sample of the organic compound. Again, I am going to brief you. For the calculation, let the mass of the sample is W gram. Now, for hydrogen can be estimated by the production of H2 molecule. The amount of H2 molecule liberated, that will be equivalent to the amount of CaCl, anhydrous CaCl2 increased, or mass of anhydrous CaCl2 increased. So increase in mass of CaCl2 is equal to the mass of water molecule. That suppose that is W1 gram. So since the molar mass of H2 is 18, it means 18 gram of H2O contains 2 gram of hydrogen. So the W1 gram of H2O will give us 2 by 18 into W1 gram of hydrogen. So we can say in the given sample, the amount or mass of the hydrogen present, that is equivalent to 2 by 18 into W1 gram. So W gram of sample contains 2 by 18 W1 gram of hydrogen. So 100 gram, percentage means 100 gram will give this very amount, 2 by 18 into W1 by whole total mass of the sample into 100. So percentage is equal to, finally we can say mass percentage or weight percentage of hydrogen is here, 2 by 18 into weight of water molecule upon weight of the sample into 100. Similarly, for the carbon, the mass of CO2 could be equal to increase the mass of KOH. That is been supposed by W2. Okay, so we can say 44 gram of CO2, that is the molar mass of CO2, contains 12 gram of hydrogen. So W2 gram of CO2 will contain 12 by 44 into W2 gram of carbon. It means 12 by 44 into W2 gram of carbon is present in the given sample. We have to make it to convert into percentages. So W gram is the mass of the total mass of the sample. So in 100 gram, it will, the carbon atom could be here 12 upon 44 into W2 upon W into 100, means mass of the CO2 12 upon 44 into mass of the CO2 or weight of the CO2 upon weight of the sample into 100. In this way, we can calculate the amount of carbon and hydrogen by following Liebig's combustion method in a given organic molecule. This is all for the estimation of carbon and hydrogen. In next part, we will discuss about the estimation of nitrogen and other elements present in the molecule. Thank you very much.